Hello students, welcome back to my channel. This is Nipa Patel from the Math Masters, and today we are going to start chapter 1, Relations and Functions, Miscellaneous Exercise according to reduced syllabus. Please like the video and subscribe to get the notifications of the new and upcoming videos. Okay, let's get to it.
Question 2. Let f w to w be defined as f of n equals n minus 1 if n is odd and f of n equals n plus 1 if n is even. So here we are given a piecewise function. Which function? That f of n equals n minus 1 if n is odd and f of n equals n plus 1 if n is even. And our domain and codomain are given this way. That function goes from w to w. W means whole number. So domain is w, codomain is w. Show that f is invertible. Now since we need to show that f is invertible, we are going to check for 1 1 and onto. If this function is both 1 1 and onto, then this function is going to be invertible. And since it is invertible, we will be able to find the inverse of this function as well. And they are here saying that here w is the set of all whole numbers. Okay, so that means whole number to whole number means domain is whole number and codomain is also whole number. Now since in this piecewise function we are given two possibilities, that your number can be odd or your number can be even as well. If it is odd, it has to follow this function definition. If that number is even, it has to follow this function definition. So from this we will be able to get four different cases, and those cases are going to be, so case 1 we are going to take as that we are going to pick any two numbers, and we are going to pick any two numbers from this domain whole number, and we are going to assume that they both are odd numbers. Okay, now in case 2 we are going to do what? Again we are going to take two numbers from this domain w, and we are going to assume that they both are even. Then in case 3, we are going to pick again two numbers, and we are going to think that one number is odd and other number is even. And in case 4, we are going to do other way around, that one number is even and that other number is odd. Okay, so let's start with case 1. And in this case 1, first we are going to check for 1 1. And for that, first we are going to pick two numbers from our domain. So let n1, n2 belongs to our domain W. What we are talking about here, domain W, and they both are odd. Okay, so we are doing our first case. In that first case, we are checking for 1 1, and that case is what? That they both are odd. Okay, now in this function definition, we are given that when number is odd, we need to follow this function definition, that f of n equals n minus 1. So if we are picking these two numbers, we are assuming that they both are odd. That means f of n1 is going to be what? This function definition. Why? Because when it is odd, we need to follow this. So n1 minus 1, and f of n2 is going to be n2 minus 1. Now to check for 1 2, we do what? We assume that this both output are same. This both values f of n1 and f of n2, they both are same. We start from here, and since we have f of n1 equals n1 minus 1, we can plug in that here, and f of n2 is n2 minus 1, so we can plug in n2 minus 1 over here. Now n1 minus 1 is equal to n2 minus 1. So that means 1 and 1 is going to cancel out, right? They both have 1 1 in it. So that means this implies that your n1 is equal to n2. That's what we wanted to show it, that the function is 1 1. That we wanted to start with assuming that they both have the same value, and then we showed that both the input are same. That's why the output is same, or this output same happens when those both numbers are exactly same. So this way we have proved in this case that this function is 1 1. So we are going to say, so f is 1 1. Why it is 1 1? Because we started with f of n1 equals f of n2, and we were able to show that that happens when n1 is equal to n2. So f is 1 1. Now we are going to do onto. So for onto, we are going to do what? We always pick one number from codomain, because how do we prove that a function is onto? We need to see that every element in the codomain that must have some pre-image in our domain, right? So we are going to pick one element from our codomain. Let that element be y. So let y belongs to w. Here this w is our codomain. Now if y belongs to w, that means there should be some x value, that when, or that should be some n value, because here they have used n instead of x. So there must be some n value in our domain, and since this is odd case, that when you do n minus 1, you get that y, right? Right now we are following that when it is odd, that means we are following that n minus 1 function. So we are guessing, we are taking one element from this codomain. This is our codomain, and this is our domain. So we are picking an element from codomain, and we are thinking that it should have some pre-image in the domain, such a way, let's call it n, such a way that when you do n minus 1, you get this y. So I can write that y is equal to, let y belongs to w, which is the codomain. That means y should be equal to n minus 1, because y is in the codomain. So there must be some value n, that when you do n minus 1, you get that y. Now when y is equal to n minus 1, I can solve that for n as n is equal to y plus 1 then, right? Now do you think that this is whole number set? This is our whole number set. This is again our whole number set. So if you pick a number, any whole number, so any whole number plus 1, will that be a whole number? Of course it's going to be a whole number. So of course this is going to belong to w. So that means this function is onto as well. And just to prove that, we are going to prove what? That f of n is equal to y. As soon as we show that f of n is equal to y, then yeah, that function is onto. But till here also, now we have gotten an idea that we will be able to find a pre-image in this whole number set, in this domain. So you are going to show that f of n. Now we are in this case that when this numbers are odd, right? When these numbers are odd, when the number that you are picking from the domain is odd. So we are going to follow again that same function definition, n minus 1. So we know that f of n equals n minus 1, and when you plug in this y plus 1 value in it, in this n, so instead of this n, we are going to plug in this y plus 1. What are we going to get? See, for n, I plugged in y plus 1. So y plus 1 and then this minus 1. So 1 and 1 is going to cancel out. So you will end up getting f of n equals y. And when you get f of n equals y, this function is onto. So we are going to say, so f is onto. Right? So now in this case 1, that when we are dealing with odd numbers, then this function is 1 1, then this function is onto. Now when the function is both, the function is invertible. So in this case the function is invertible, and inverse of this function, and inverse of this function is going to be, so if your f of n is equal to y, that means inverse is going to be what? F inverse of y is going to be n, right? And what was our n value? Y plus 1. So what is your inverse? F inverse of y is going to be equal to y plus 1. So this is the inverse that you found when your n is going to be odd, right? What did we say? when your n is odd, right? When n is odd. But you'll say that, why you are writing that when n is odd? We don't even have this variable n in here. So we are going to try to rewrite this as when y is something odd, even, whatever y has to. Let's see what it's going to be. So your n is equal to y plus 1, right? Now when your n is equal to y plus 1 and when your n is odd, see, this inverse you got when your n is odd, and your equation in between n and y, or the relation between n and y we established here, was what? N equals y plus 1. So when n is going to be odd, y is going to be what number? Odd equals what number plus 1? So it must be what? Even. So this we found when y is even. So f inverse of y equals y plus 1 when y is even. So this one part we finished, that is our case 1. Okay, now we are going to start doing case 2. Now in that case 2, see, case 1 we picked n1 and n2 both odd numbers. So now it's turn to pick and to assume that, n1 and n2 from the domain, but let's assume that they are going to be even. Okay, so now for that, okay, I can do even here as well. Okay, so now we are doing case 2, and case 2 is what? That they both are going to be even. First we are going to start with 1 1. Now in that 1 1 you are going to again going to write that assumption that n1 n2 they both belong to the whole number. Which whole number? Our domain, and they both are even. We are going to do exactly the same thing whatever we did in this case 1, that we are going to do 1 1, then on to, if it's going to be both of them, then it's going to be invertible, we are going to find the inverse as well. Okay, so this is our case 2. We are doing 1 1. We are assuming that this both numbers lie in our domain and they both are even. Now if it is even, it's going to follow which function definition? See, f of n equals n plus 1 when n is even. So we are going to follow that n plus 1 function definition. So f of n1 is going to be what? It was n plus 1, that means n1 plus 1. That means f of n2 is going to be n2 plus 1. Now to prove 1 1, we start with assuming that both output are same. Both function values are same, that f of n1 is equal to f of n2. That means n1 plus 1 is equal to n2 plus 1. Now this 1 and 1 going to cancel out. That means you are going to end up getting n1 equals n2. So as soon as you start with this and you get n1 equals n2, means f is 1 1. Okay, so now we are going to start for onto. Again, same way, we are going to take a codomain. We are going to take an element from this codomain. This function is what? Even, so it is getting n plus 1 from here to here. Now let's pick some element from the codomain y. Let's write that down here. Let y belongs to w. Which w? Our codomain. Now if this y is in our codomain, if the function machine is n plus 1, there must be some n somewhere here, that when you do n plus 1, you get that y. When you do n plus 1, you get that y. That means I can write y is equal to n plus 1 because you had some n. When you did n plus 1, you got y. That means y is equal to n plus 1. And since y is equal to n plus 1, if I try to solve this equation with respect to n, then n is going to be y minus 1. Now, if y was a whole number, see, this was whole number set, this was also whole number set. If you have a whole number in here, and if you subtract 1, do you still get a whole number? Yeah, of course, we are still going to end up getting a whole number only because you are subtracting 1 whole. So you are going to end up getting a whole number, and this is going to belong to W. This is going to belong to W. So now we can say it is on 2, but just after one step. What step? We are going to show that f of n is equal to y. To show that, we are going to do that now f of n. See, we got some n here, and output of that value, function value of that was y. So in this case, it was what? N plus 1, right? That function definition was n plus 1. And if you plug in this value, which n value, y minus 1 in here, what's going to happen? Y minus 1 and then this plus 1. For this n, you plugged in y minus 1. Now you are adding 1 to it. This is and this is going to cancel out. So see, we got f of n equals y. As soon as we get that, we can write what? F is on 2. Okay, now this function is, in this case, 1, 1 as well, on 2 as well. So of course you will be able to find the inverse because it is going to be invertible, right? So this function is invertible, and inverse of this function, so you are going to see that this y was nothing but what? F of n. So y was nothing but f of n. That means I can say f inverse of y is equal to n, but n is equal to y minus 1. So you can say f inverse of y is equal to y minus 1. This is the inverse when n is even. When n is even. Why? Because that was our case, right? That when they both are even. So when they are even, we found that inverse is going to be this. But our inverse is in terms of y, and our condition is in terms of n. So we need to change this n into y, right? The same way that we did in here. See, here our inverse function was y plus 1 when n was odd, and then we figured out that when n is going to be odd, y is going to be what? In this case it was even, so we change this condition from n is odd to y is even, right? So same way we'll have to do this as well. Why? Because we cannot have function in terms of y and then condition in terms of n. It must be in terms of y only, right? So right now your inverse function is this, that f inverse of y equals y minus 1 when n is even. Okay, now n is what? Y minus 1. N is y minus 1. And n, we are assuming that this is even. So what number? Or you can think this way, that f n plus 1 equals y. So even plus 1 equals, it's going to be odd. So if this is even, then y is odd. So that means this inverse function, that f inverse of y equals y minus 1, that's going to happen when y is odd. So our final answer is going to be this, that f inverse of y is equal to y minus 1 when y is odd, and f inverse of y equals y plus 1 when y is even. So we found the inverse function, and in this both cases, in case 1 and case 2, in this case 1 and in this case 2, this function was 1 1 and onto both, so it was invertible. Okay, now we need to do case 3. Okay, so let's start doing case 3. Now in case 3, we are going to take what? One number odd and other number even. So when, let's say n1 is odd and n2 is even, and n1 and n2, they both belong to W, which W? Our domain. Okay. Now to prove it to 1, 1, what is our first step? That we find f of n1. What is our f of n1? When n1 is odd. So our function definition was what? That when n is odd, n minus 1, right? What was that? When n is odd, you follow n minus 1. So if n1 is odd, then it is going to be what? N1 minus 1, and n2 is even. So f of n2 is going to be what? See, when your number is even, you follow n plus 1. So f of n2 is going to be n2 plus 1. Now to prove 1, 1, we start assuming that f of n1 is equal to f of n2. Now this is going to happen when n1 minus 1 is equal to n2 plus 1. Now this means what? That n1 minus n2 is equal to 2. I just brought this n2 this side and I am sending this negative 1 on the other side. So n1 minus n2 equals 2. Now n1 was what number? Odd. Odd minus n2 was even. So do you really think that this is ever going to happen, that odd minus even you are going to get 2? No, you are always going to get odd. So this is never going to happen. Your n1 minus n2 is never going to be 2 when this condition is there. So this case is not possible. So this case is not possible. Let's try doing our case 4 then. Now we are just going to do other way around in case 4 than case 3. We took n1 equals odd. So here we are going to take n1 equals even. Let n1 is even and n2 is odd, and n1, n2, they both belong to our domain W. Okay, same way. We are going to find f of n1, we are going to find our f of n2. Now n1 is even. Now if n1 is even, you are going to have what equation? N plus 1. So let's plug in that in here. So I'm going to write n1 plus 1. Now if n2 is odd, that means which function definition? N minus 1, right? That's what we were given. So f of n2 is going to become what? N2 minus 1. Now to prove it to 1, 1, we always start with what condition? That f of n1 is equal to f of n2. Here n1 plus 1 and here n2 minus 1. Now simplify this. So if I send n1 over there, 1 over here, I am going to get n2 minus n1 equals 2. Now let's think a little bit. N2 is odd. So odd minus n1 is even. See, n1 is even, n2 is odd. So odd minus even. Will you ever get 2? You will never get even number. It is always going to be odd. So this is never going to happen. So these are never going to be equal to each other. So that means again this case is not possible. So not possible. So whichever cases were possible, this case 2 and this case 1, they both were possible and they both were 1, 1 and on 2. So that means they both were invertible. That means we were able to find inverses for them, and they were what? That inverse of this first case was f inverse of y is equal to y plus 1 when y is even, and the other inverse for that second case was what? That f inverse of y is equal to y minus 1 when n is even. So just to wrap up, we are going to write our final answer. And that final answer is going to be what? Because our question was what? Look here. See, our question was, show that f is invertible. We showed that because it was 1 1 and on 2, and find the inverse of f. We found those inverse of f. It's just that they are like on the different sides of the worksheet. So we are going to wrap up by writing just one f inverse of y, and that's going to be what? That f inverse of y is equal to y plus 1 when y is even. Y plus 1 when y is even. Yeah, see, that's what we got. And then y minus 1 when y is odd. So this is our inverse function that they were looking for in our answer. Y plus 1 when y is even, and y minus 1 when y is odd. Yes, y minus 1 when y is odd. Question 4. Show that the function f R2 x belongs to R where x is in between -1 to 1 defined by f of x equals x over 1 plus mod of x where x belongs to R is 1 1 and onto function. So first write down this function goes from what domain to what codomain. So this is simple enough that your domain is all real numbers. But your codomain is what? See, you are given that your x belongs to the real number set as long as that x is in between -1 to 1. So we can just write -1 to 1 in the open interval. Why? Because you were given less than, not less than or equal to in here. That means your x must be greater than this -1 and your x must be less than this +1. So that means we need to use this open parenthesis. So our function domain is all real numbers. Codomain is from -1 to 1 in open interval. Now what function definition you are given? This is, so f of x is equal to x over 1 plus mod of x. Now we know the definition of mod of x, right? That mod of x implies what? That it is going to be x when your x is greater than or equal to 0, and it's going to be negative x when your x is less than 0. So same way we can add this in here and we can make this as piecewise function. So I can rewrite this f of x as x over 1 plus. Now instead of this mod of x, if I assume that x is greater than or equal to 0, when I assume that x is greater than or equal to 0, I can write x instead of this mod of x. So x over 1 plus x when your x is greater than or equal to 0, and x over 1 plus. Now instead of mod of x, I need to write negative x when x is less than 0. So when x is less than 0, I need to write negative x in here. But instead of writing this plus and negative, I am just going to make it negative x. Because that was nothing but what? 1 minus x, right? 1 plus negative x is what? 1 minus x. Okay, so our piecewise function is ready now. This x over 1 plus mod of x is nothing but what? This piecewise function. We got two conditions, that when x is greater than or equal to 0, we need to follow this function definition, and when x is negative number, then we need to follow this function definition. So again, we will be able to find 4 different cases. First 2 cases are important that you are supposed to show. Third and fourth case, if you show, not show, it's not going to matter that much because those are going to be impossible cases like our question 2. Okay, so let's start with our case 1. Now in case 1, we are going to assume that our x1 and x2, they both belong to R, which are our domain. Of course, I think now when I write R, you will be able to understand that it's domain. Why? Because our codomain is from -1 to 1, right? So let's say that x1 and x2 belongs to R, our domain R, and right now we are showing our 1 1 possibility in our case 1. And let's assume that x1 and x2, they both are greater than or equal to 0. Why? Because in our case 1, we are going to assume that this both are positive number or 0. So x1 and x2 greater than or equal to 0. That we are assuming in case 1. In case 2, we are going to assume that they both are negative numbers. That means less than 0. In case 3, we are going to take x1 as a positive number like greater than or equal to 0 and x2 as less than 0. And in case 4, we are going to take x1 as negative number and x2 as greater than or equal to 0. Those 3 and 4 cases are not going to be possible. So if you show them, not show them, it's not going to make any much difference. I'm going to show you guys. But this case 1 and case 2 are important cases. For this case 1, we are taking x1 and x2 both greater than or equal to 0. And we are picking them from our domain as usual while we are showing that whether the function is 1, 1 or not. Okay, now our next step is always what? When you pick two elements from your domain, you find your function value at those points. So f of x1 is going to be what? Now we are following which function definition when x1 and x2 they both are greater than or equal to 0. That means we need to follow this function definition, x over 1 plus x. So f of x1 is going to be what? x1 over 1 plus x1, and your f of x2 is going to be x2 over 1 plus x2. Now we always assume what? That our f of x1 is equal to f of x2. Now if these two are same, that means x1 over 1 plus x1 is going to be equal to x2 over 1 plus x2, and this is going to give you, do cross multiplication. So if you do cross multiplication, x1 times 1, x1 times x2, so x1 x2, and here you are going to again cross multiply. So x2 times 1, x2 times x1, again x1 x2, and this is going to become, now both sides you have x1 x2 x1 x2, it's going to cancel out, right? And you are going to left with x1 equals x2. Now when we start with this and we get this result, means your function is 1 1. So in this case your function is 1 1 when they both are greater than or equal to 0. Now let's check for onto for the same case. So onto. Now for onto we always do what? From our this diagram, let me call this our domain. This is our codomain. And since they both are greater than 0, we are following which function definition? That x over 1 plus x. And let's pick some value from this codomain. So for onto we always let one value, and that is, since our codomain, since our output we call it y mostly, so y, let y belongs to, now in this case it's going to belong to what? Our codomain is from -1 to 1. In this case we are taking that 0 to positive side, so I don't need to write from -1 to 1, I can write from 0 to 1. Does that make sense? See, x1, x2, they both are positive numbers, right? So if they both are positive numbers, then this case we are taking as positive side, right? So we are going to take our y also on the positive side, which is going to be from 0 to 1. So let's say that your y belongs to that positive side of -1 to 1. So that means from 0 to 1. I'm including 0 in here. And since 1 is not in your codomain, we are going to have that open parenthesis here and closed parenthesis in this side. Okay. Now, since we are assuming that our numbers are positive number, so if a number is a positive number, then of course, see, if x is positive, if this is positive, so positive over 1 plus some positive number, you are going to get positive. See, that's why I picked your y from the positive side of -1 to 1. Does that make sense? Sure. Okay, one more time. Why we are saying that our y is going to belong to 0 to 1? Because we are picking that our domain. Right now we are guessing in this case 1 that our domain, we are picking some number which is positive from this domain. So if that number is positive, we are going to follow this function definition. And if you are going to plug in some positive value in here, so positive value divided by 1 plus some positive value, of course you are going to get a positive number, and that's going to be in between 0 and 1. Why? Because denominator is bigger than your numerator. See, if you are going to pick 5 here, if you are going to plug in 5 in here, then this is going to be 6. So of course every time your denominator is going to be bigger than your numerator, so your codomain, your output with respect to that input is always going to be less than 1. That's why see, our y belongs to, in this case, from 0 to positive 1, where it does not include that 1. Okay, now since function definition is x over 1 plus x, we are picking some y from our codomain. We will be able to connect that to some x, that when you do x over 1 plus x, you end up getting that y. So I can write what? That y is equal to, I can write that y is equal to x over 1 plus x, right? This y we got by doing what? X over 1 plus x. And if this is true, that means I can do cross multiplication, because my aim is to solve this equation for x. Right now this is solved for y. I want to solve this same equation but for x. So I'm going to do what? Multiply this. So y plus xy is equal to x. Since we want to solve this equation for x, we have to have all the terms, all the x terms on one side of the equation. So I'm going to simplify this furthermore, and this is going to be x minus xy. Now we are going to take x in common, because x is in this both terms. So if I take x out, then 1 minus y, and that means now I can solve this equation for x, which is going to be y over 1 minus y. Now think, is this going to belong to R? Because we need to check. We started from a value from codomain, and we are checking that will we be able to find that pre-image in the domain. Our domain is real number set R, right? Our domain is our real number set R. So this, if you pick any value from 0 to 1, and if you use this y over 1 minus R, will that number going to be lie in real number? Will that number is going to be a real number? Of course it's going to be a real number, right? So this function is onto, but we need to show one more thing. Which thing? That we need to show f of x is equal to y. As soon as you show this, that function is onto, right? So now we are going to do what? Our function definition was f of x equals, function definition is x over 1 plus x. Now wherever we see x, we are going to plug in this value. Wherever we see x, we are going to plug in this value that we just found for x. So instead of x, I am going to write y over 1 minus y, and in denominator as well, that we got x in there. So I am going to write y over 1 minus y in there as well. Now let's keep on simplifying. This is y over 1 minus y. For now, let me keep that as it is. What I want to do is I want to write this 1 minus y as the common denominator in this denominator. So I need to multiply this 1 times 1 minus y. So 1 minus y, then this y, so plus y, again all over 1 minus y. So 1 minus y, 1 minus y, we will be able to cancel out, and this is going to be what? This y and this y also cancels out. See, negative y, positive y. So y over 1, you are going to end up getting y as your f of x. That's what we were looking for to make that function onto. So since f of x is equal to y, f is onto, right? So for case 1, we were supposed to show that this function is 1, 1, and onto function. We just did that. But we just did for one case. We need to do exactly same thing. All the things that we have done till now for that case 2. So let's do our case 2. And in case 1, we assumed what? That both the number were greater than or equal to 0. Now we are going to do less than 0 in this case, right? Okay, so case 2, and we are going to do again 1 1 first, And we are going to say what? That let x1, x2, they both belong to R. See, they both belong to R. What? Domain. In our case, this is domain. And this time we are saying that x1 and x2, they both are less than 0. Now, if they are less than 0, which function definition they have to follow? X over 1 minus x, right? So now we are going to find f of x1 and f of x2 for that case too from this function definition, x over 1 minus x. So f of x1 is going to be x1 over 1 minus x1 and f of x2 is going to be x2 over 1 minus x2. What we do to prove that function is 1, 1? We assume that both the function values, f of x1 and f of x2, they both are same. Now that means this and this are same. So x1 over 1 minus x1 equals x2 over 1 minus x2 are same. And that means I can do cross multiplication. So x1 times 1, x1 times negative x2, negative x1, x2. Then x2 times 1, x2 times negative x1, negative x1, x2. Now see, both sides we got negative x1, x2. So I can cancel out this. And since I can cancel out this, the result is nothing but what? X1 equals x2. So when we start with this and we get x1 equals x2, means we can write function is 1, 1 because that function is 1, 1. Now let's start checking for onto. Again for onto we are going to, this is our codomain, this is our domain, this is our R, this is the possibility that we are thinking that both are less than 0, so x over 1 minus x. So this function definition is x over 1 minus x. And let's say that there is some element in this codomain and there is some input here. There is some element in here in domain. There is some pre-image in this domain. Let's call it x. And when you do this x over 1 minus x, you get to this y. That's what we are assuming right now. So I can write what? Let y belongs to, now in this case it is going to belong to what value? From negative 1 to 0. Let's say that y belongs to negative 1 to 0. Why? Because our x1 and x2, they both are negative. So if you have a negative number, this is just a rough work I am showing you. You don't have to show that in your answer sheet. See, we are talking about this function definition right now. So when your input, see right now in this case x1, x2, they both are negative. x1, x2 less than 0 in this case. We are doing case 2. So if this number is negative, that negative over 1 minus again some negative number. So this minus some negative number. So denominator will be positive, of course, right? Because you are actually going to end up adding these two numbers. So your denominator is going to be positive, but numerator is negative. So your y value is going to be negative. And since your y value is going to be negative, we are going to look at the negative side of this codomain. And negative side is what? From negative 1 to 0. Okay, so that's why this is the reason why I wrote that let y belongs to negative 1 to 0. Now, what did we say? If there is some pre-image x and from doing this function definition, let's say we are getting that y. So that means I can say that y is equal to x over 1 minus x because there we are assuming, we are guessing that there was some element x, and when you did this function definition, then you got to that y. Okay, we are talking in other way around, but just to make you understand that that function definition works actually this way, we are just going on the other way around. But still your y is equal to what? X over 1 minus x. Now let's simplify this equation in terms of x. Right now this equation is solved for y. We want to solve the same equation for x. So we are going to multiply y times this 1 minus x. So y minus xy equals x. I need to gather both the terms, both the x terms on one side. So that means y equals x plus xy. And then you are just going to take that x in common. So 1 plus y. And now it is easy to solve for y. So y over 1 plus y. Now think, is this going to belong to R? Do you really think that it's going to belong to R? See, our x, that means this number. We are guessing that that is negative. See, we guessed this is our case 2 where we are guessing that this input is negative. So if you plug in some value, right, or think this way, our y was from negative 1 to 0, right? So if you plug in some negative number in here or even 0, if you plug in some negative number from negative 1 to 0, any number in here, then will you get some number here which is a real number? Of course, whatever number you pick, negative 0.5, even 0, whatever number you plug in here, you are going to get your x as a real number. That means it's going to belong to your domain. Your domain is all real numbers. So no matter what element you pick from your codomain, you'll be able to find the pre-image in your domain. And when this happens, that function is onto. Why? Because this was possible value in your domain. That means you will be able to find a pre-image. That means your function is onto. And just to show that one more step, we are going to show what? That your f of x is equal to y. To show that, we are going to say that since that function definition was x over 1 minus x, that means f of x is x over 1 minus x, and wherever you see x, just plug in this y over 1 plus y, right? So when you do that, equals, now wherever you see x, plug in y over 1 plus y over 1 plus y, and here 1 minus again x, so plug in y over 1 plus y. Now try to solve this. So when you solve this, numerator I am going to write as it is for now. Denominator, I want to multiply this 1 times 1 plus y, so I can write this 1 plus y as common denominator. So 1 times 1 plus y, I am going to get 1 plus y, and then minus y, so minus y. Now see, 1 plus y both same, so they are going to cancel out. Here it is positive y, negative y, this is going to cancel out. So you are going to end up getting what? In numerator y, in denominator this one. So that means you are getting f of x is equal to y. That's what we wanted to show, that that function is onto. So you are going to write what? That since f of x is equal to y, f is onto. Okay, so that's what we were supposed to show, that your function is 1 1 and onto. Now when you if you end your question here, that's totally fine, but logically you should consider the other possible cases as well. You still have two more possible cases which are not going to be possible, but we need to show that they are not possible. So case 3 we are going to do here, and case 4 we are going to do here. It's not going to take much time. So here we are going to say that let x1 and x2 belong to R. What we are talking about? Domain. Now if it is in the domain, and we already covered that x1 and x2, they both are greater than or equal to 0. We already covered that they both are less than 0. So this case can be what? That let that one value, so belong to it, and x1 is greater than or equal to 0 and x2 is less than 0. So that means in case 4 we are going to take what case? That again x1, x2, they both belong to R. Again we are talking about domain, and we are going to take other way around, vice versa. So x1 is less than 0 and x2 is greater than or equal to 0. Okay, so let's finish this case 3 first, and then we'll move on to that case 4. Now, if I say that f of x1 equals f of x2, in this case, when your x1 is greater than or equal to 0, and when your x2 is less than 0. Now, when x is greater than or equal to 0, our function definition is x over 1 plus x. So, x1 over 1 plus x1. Now function definition for your x less than 0 is what? X over 1 minus x. So in this case x2 over 1 minus x2. Now you are going to do what? Cross multiplication. If you do cross multiplication, you are going to end up getting x1 minus x1 x2 equals x2 plus x1 x2. Now this both are like terms. I'm going to send this over there. It's going to become 2x1 x2. I'm going to send this x2 over this side. So x1 minus x2. So here I got what? X1 minus x2 equals 2x1 x2. Now x1 is what? Positive number, right? So this is positive number. Your x2 is negative number. So if you subtract a negative number, you will end up getting a positive number. Your result is going to be a positive number. Does that make sense? One more time. Your x1 is positive number. So this is positive. Your x2 is negative number. You are subtracting that negative number. So this negative and negative, this is going to make it positive. So you are going to end up adding two numbers, and if you add those two numbers which are positive, you are going to end up getting a positive result here. This both together will give you a positive. Now what happens here? Your x1 is positive, but your x2 is negative. So if your x2 is negative, then negative times positive, 2 is already positive. So this is going to end up being a negative number. How can a positive number and negative number can be equal? Not possible. So this case, not possible. This case is not possible. Now same we are going to do in case 4. Again we are going to start with, let's say, f of x1 is equal to f of x2. Now this time our x1 is less than 0. So we are going to follow function definition x over 1 minus x. So x1 over 1 minus x1. Now x2 is positive this time. So x over 1 plus x, that function definition we are going to follow. So x2 over 1 plus x2. Now do cross multiplication. You are going to get x1 plus x1 x2 equals, now this cross multiplication. So x2 minus x1 x2. Now okay, I'm going to send this over this side. So I'm going to end up getting 2x1 x2, and now I'm going to send this over there. So x2 minus x1. Okay, now same logic. Whatever we applied here, we are going to think same thing over here as well. So x1 is negative number. So negative number, x2 is positive number. So this is positive. So when you multiply 2 times some negative number times some positive number, of course you are going to get a negative number, right? And here your x2 is what? Positive number. Now you are subtracting. You are subtracting. Let me write closer to that x2. So this x2 is a positive number, and this x1 is less than 0. So this x1 is a negative number. So when you subtract a negative number, see this sign is already there. I am not talking about this sign. This x1 was negative. See, this x1 was negative. Now you are subtracting that negative number. So it's going to become positive. So positive plus some positive number. Of course, you are going to get a positive number. So how can a negative number and positive number are equal? Not possible. So again, this case is not possible. Okay, so since these two cases are not even possible, that means we just need to conclude our answer from case 1 and 2 that they both were 1 1 and on 2, and we just showed that case 1 was both of those and case 2 was also 1 1 and on 2. Question 5. Show that the function f from real number to real number given by f of x equals x cube is injective. Injective means 1 1. Now if we just look at that domain and codomain and try to understand the situation, this is our real number, this is our domain, this is our codomain, all real numbers. So like bunch of, like, from negative infinity to whatever rational, irrational number you can think of, all numbers are in here. -2, -1, then 0, 1, 2, and like lot more. Not just integers, every decimal, fraction, square root, cube root, whatever you can think of, all real numbers are in here. Same way here also you have like lot of values. Let's say -8, -1, 0, 1, 2, 8, and infinitely more, right? So now function is what? That it is f of x, and when you cube that input you get the output. So cube of -2 you are going to get -8, cube of -1 you are going to get -8, sorry, cube of -1 you are going to get -1, cube of 0 you are going to get 0, cube of 1 you are going to get 1, cube of 2 you are going to get 8. So looks like one value from here is connected to only one value from here, or vice versa. Only one value from here is connected to only one value from here. That means this function is 1, 1, definitely 1, 1. And 1, 1, the other word for 1, 1 is what? Injective. So that means this function is injective. But we need to show in a proper way. So you don't have to show this. This is just for me, trying to visualize you that why this is 1, 1. Okay, so here you are going to say what? That let x1, x2, they both belong to R. Which R we are talking about? Domain. They both belong to this domain, and that means f of x1 is going to be what? This is our function definition. So x1 cube, and f of x2 is going to be your x2 cube. Now we think that both values are same, that f of x1 and f of x2 are same. That means your x1 cube is equal to same as your x2 cube. And when is this going to happen? When your x1 is equal to x2. And when you start with this, when you get x1 equals x2, that is clear cut case of when your f is injective. Injective means 1, 1. Since they are using injective, I used injective. Okay, so your function is injective. That's what you were supposed to show. We just showed that.
Okay, so that's it for this video. We'll do remaining questions in the next video. Please like and subscribe. See you all soon. Bye.